Earlier, we saw a relationship for a multiplication property for square roots and a division property for square roots, that the square root of the quantity a times b could be split up into the square root of a times the square root of b. Or the square root of the quotient a over b became the quotient square root of a over the square root of b. That rule that we have worked with previously is actually a specific version of this more generalized form that is true for any nth root. For any positive numbers x and y, we have a multiplication property for all roots. The nth root of the quantity x times y is equal to the nth root of x times the nth root of y. And similarly, the nth root of x divided by y can be rewritten as the nth root of x divided by the nth root of y. We can use these properties to both combine and separate out radicals like we've done before. In the next two examples, we want to simplify the radicals using either the multiplication or division properties for roots. In part A, we have the third root of 54. To make use of this multiplication property for roots, we need to find a perfect third power that divides into 54. Our goal is to separate 54 into the product of a perfect third power and some other factor. The nice thing is, when we're working on an example like this, we only have to worry about factors of 54 that are perfect third powers. And from my list of perfect third powers, I know that 2 to the third is 8, and 8 does not divide into 54. I know 3 to the third is 27, and 27 does divide into 54. So I can rewrite 54 as 27 times 2, meaning I'm going to rewrite the third root of 54 as the third root of the quantity 27 times 2. And then using our multiplication property for roots, I can split this into two separate radicals, the third root of 27 multiplied by the third root of 2. The reason for doing this, the third root of 27 simplifies down to 3, and the third root of 2 cannot be simplified. So a simplified version of the third root of 54 is that it is 3 times the third root of 2. In part B, we now have the negative fourth root of the fraction 1 over 16. The first thing here is to recognize that negative is outside of the radical, so it really means negative 1 times this radical. So I'm going to rewrite this as negative 1 times, and now on that radical that is the fourth root of a fraction, I'm going to split this up. I'm going to rewrite that as the fourth root of 1 over the fourth root of 16. When simplifying this, it turns out that these are both nice fourth roots to be dealing with. The fourth root of 1 is 1, and the fourth root of 16 is 2, because 2 times 2 times 2 times 2, or 2 to the fourth power, is 16. So simplifying this, I get negative 1 times 1 over 2. And negative 1 times 1 over 2 is simply negative 1/2. So we can use the multiplication property for roots and the division property for roots in the similar way that we did when we did this with square roots. It is simply more generalized, and you have to connect the index with what power you're looking for. If I was taking the fifth root of some number and trying to simplify it, then I would need to find a fifth power that was a factor of what was underneath the radical.